So my project was predicting the greenhouse gas emissions of hydroelectric dams using supervised learning in collaboration with the Institute for Computational Sustainability. So hydroelectric dams actually contribute large amounts of greenhouse gas emissions, and the goal of this project was to predict the emissions of a dam based on environmental attributes and physical attributes of the dam. And the ultimate goal was to help influence policy decisions regarding newly proposed dams, which means that interpretability was a key concern. So I focused on tree-based models. So I was given access to a ton of data. There were over 3,000 features for around 800 dams. So there were around 800 training examples. So I tried to whittle down the number of features to consider using feature selection methods. The first method I used was looking at Gini impurity scores, different features, and then I looked at the permutation importance scores of features. And then the third feature selection method I tried was training lasso linear models and looking at the features with the highest coefficients that were non-zero. And to solve the actual problem, I chose to train XGBoost models because of their, the gradient boosted ensemble framework is highly effective on a wide variety of problems. So first I trained on the original data set from Laura and Yiwei, and the performance was significantly a huge improvement from their previously trained linear models. So it was an exciting result. Then I trained on all 3,000 features, and the performance was slightly worse than just training on the original data set. And then I trained on the original data set unioned with all of the top 40 features from each of the feature selection methods, and this was the best performing model. And then finally I trained a model only on the HydroAtlas features, which is probably the model that would be used in practice because power generation and physical attribute data is limited for newly proposed dams. But the performance was worse than the other models, but it actually was surprisingly good. So it's an exciting result, and who knows, maybe this could be used. So yeah, thank you.